So this first one is saying we want to find the area of the region between this graph and the x-axis from 3 onwards. So that means from 3 to infinity. So we're doing the integral from 3 to infinity e to the negative 2x dx. And so the problem is that one of those boundaries is not a value. So we're going to do limit as b goes to infinity, and we usually use a for the lower boundary and b for the upper boundary. This, whatever letter of the alphabet you use for that, it really doesn't matter. You can't use x because we already used x, but whatever else you want to use, fine. Integral from 3 to b e to the negative 2x dx. And so that limit is just going to kind of follow us along until the very last line here. We're going to do the antiderivative. Now there would be a u substitution for this part, and you're welcome to write all that out if you want to. We're just going to need a negative 1/2 to adjust for the negative 2. So it's going to be negative 1/2 e to the negative 2x integral from 3 to b. Again, if you want to write out those steps of the u substitution, that's fine. It's just going to be an adjustment of a negative 1/2. And so we're going to do upper boundary minus lower boundary. So plugging in b here, this would be negative 1/2 e to the negative 2b. I'm going to put that in the denominator since it is a negative exponent. And then minus the lower boundary, negatives are going to cancel. It'll be 1/2 e to the negative 6. So again, I'm going to put that in the denominator since it's a negative exponent. And so the final step is we're going to do this limit. You can't plug in infinity, but imagine plugging in the biggest number your imagination allows for this b value. You're going to have 1 gazillionth, which is essentially nothing. So this part goes to 0 plus 1/2 e to the 6th. And so our answer is A. All right, the second one was already set up for us. Our upper boundary is infinity. So this will be limit as b goes to infinity, integral from 1 to b of this thing. So again, you're really just moving the problem. This was the issue, so we just sort of wrote it out front as a limit and called it something else. And so this is going to be limit as b goes to infinity. And we are going to need a u substitution for this one. This one's a little bit more, there's a little bit more to it, so I'm going to actually write this one out. U is going to equal this inside part. So that derivative is 2x dx. And I'm going to need to adjust with a 1/2. So the x dx is what I'm substituting out, and in its place, I'm going to put 1/2 du. And what's still there is this u squared that's in the denominator. So that would be u to the negative 2. So doing that antiderivative, it would be u to the negative first, and then I would need a negative out front. And the 1/2 is kind of just there. And then I need to put this statement back in for u. So it is going to be negative 1/2, and the u statement will go in the denominator because of the negative exponent. So this 1 plus x squared is going to go down there. And it'll be such that, and my boundaries were 1 to b. So we're going to do upper boundary minus lower boundary. So plugging in b, this will give us negative 1/2, 1 plus b squared, minus negatives, that's going to cancel, 1 over, let's see, 1 squared will be 1, plus 1 is 2, and then double that will be 4. So again, as we go to infinity, this part is going to get infinitely large. So 1 trillionth is essentially nothing. And then plus a 4th is going to give us a 4th. So this one will be C. And the rest of these were review questions. These problems are long. I don't want to give you like more than just a couple of those. I think it's good for us to be doing review all year long. So This one says the maximum acceleration on the interval 0 to 3 by a particle whose velocity is given by this. Okay, so the first thing we need to do is get the acceleration. If we want the maximum acceleration, we're going to need a function for acceleration. So that will be derivative of velocity. So 3t squared minus 6t plus 12. And it said we want the maximum acceleration. So I want to know when this is a maximum. And so I need the critical points of this function. So we are going to actually need to take the derivative of acceleration because it said maximum acceleration. So I need the critical points for the acceleration function. So that would be 6t minus 6. We're going to set that equal to 0. And so t would be 1. So this is our candidates test. And we're going to test our critical points and our end points. So 1 is our critical point, and our end points are 0 and 3. So we're going to plug each of those into the acceleration and see which one comes out the biggest, and that would give us the maximum acceleration. So if we plug in 0, that's going to be 12. If we plug in 1, that's going to be 3. Minus 6 will be negative 3, plus 12 will be 9. And if we plug in 3, 3 squared is 9, times 3 will be 27, minus 18, plus 12. So that'll be 27 minus 6, so 21. And so out of those options, 21 is the largest one, so that is D. All right, number 4, we want the area between this graph and the x-axis from 1 to 2. So we're going to integrate this function from 1 to 2. So this antiderivative would be x to the 4th plus 2x such that 1 to 2. And we're going to do upper boundary minus lower boundary. So if we plug in 2 to the 4th would be 16. 2 times 2 would be 4. So 16 and 4 would be 20. Oops. I was about ready to write 60 there. 20 minus, and if we plug in 1, that'll be 1 plus 2 will be 3. So 17. So that one is D. Right, number 5, they're giving us values for the second derivative and then asking which statement must be true. So these first few are talking about increasing and decreasing. It's the first derivative that tells us about increasing and decreasing and local maximums and minimums. So we have the second derivative. We need to look at the inflection points in the concavity. So it's going to have to be either D or E because that's what the second derivative tells us about. So let's read D. The graph has a point of inflection at 1. This is a little tricky because the second derivative equals 0 at 1, and we have a positive and then a negative, so it looks likely. But here's the thing. We don't know what happened in between 0 and 1. Say at like 0.5, this went down to like -3. And then both sides would be negative, and we wouldn't get a point of inflection there. There wouldn't be any change. So we don't know exactly what happened in between 0 and 1, so we can't guarantee that. E says the graph changes concavity on the interval 0 to 2. Okay, well here's 0 to 2. And I see positive values for the second derivative and negative values for the second derivative. So I know that we were concave up and then concave down at some point. So there had to be a change in concavity. So that one is E. All right, 6 says the horizontal line y equals 2 is an asymptote. So that means that this graph levels off at 2 on the side. So which statement has to be true? The limit as we go to infinity would have to be 2, since the graph is leveling off at 2 on the side. So that one is E. All right, this one is limit as x goes to infinity. That's comparing the powers of the numerator and denominator. This is like who's in charge here. So for the numerator, it is the x squared And for the denominator, it is the negative 4x squared. So when it is a tie like that, we're going to use the coefficients. And so this coefficient is 1, and this one is negative 4. So that one is B. And then the last one, it says the limit as x goes to 3 of the function is 7. Which of the following must be true? Here's the thing, a limit does not really guarantee you very much. All it says is that there's behavior of the graph around that point. So at the point 3, 7, all we know is that there's a limit. So all we know is that both sides are headed towards 3, 7. I don't know necessarily what's going on there. All I know is that both sides are going there. So is the function continuous? Well, not necessarily. There might not even be a point there. There doesn't have to be for there to be a limit. So we're not necessarily continuous. And if the function's not continuous, then it can't be differentiable. And then the third one is f of 3 equals 7. Well, maybe not. We might not have a point there. It could be missing, or the point could be somewhere other than 7. It could be somewhere else. So we actually aren't guaranteed any of those things. A limit does not guarantee you anything besides behavior. All you're told is that both sides are coming towards that point.